everything. So assuming that that's working, let's go ahead and Alright, so in this video we're going to be adding a little bit, just a tiny little different element to our network, which is the network time protocol. So at this point, in order to do this section, in order to complete it, all of your IP addressing has to be complete and EIGRP has to be functional. You have to have end-to-end connectivity between all devices. Otherwise, you will not be able to successfully implement NTP on everything. So assuming that that's working, let's go ahead and just do a couple of, as we can see here, 3 tasks, which is pretty quick. So number 1, set the local clock on R4. Okay, so like I've been doing before, how would you do this? Go ahead and tell me at what mode would you implement the command and what command would you implement on R4 to accomplish task number 1. So the command we're going to be using here for this is the clock set command. And this is one of those weird commands, one of the only ones I can think of, where you actually implement it at privileged exec level. Yeah, weird. Normally we think of configuring things at least at global configuration mode, if not deeper. Clock set, that's actually something you do at privileged exec level, at the enable prompt. Not sure why they have it there, but it is. So let's go ahead and go into, we're told to do this on router 4. So we're going to do clock set and then the hours, minutes, and seconds. And this is in military time, 24-hour time. So for us, I'm going to just do it for myself locally here. Right now it's 1:36, so that would be 13:36:00. And then it is currently, lost track of time here. It's the 29th of July, 2015. And now the clock has been set. Okay, so that accomplishes task number 1, locally setting the clock. And the reason why we did that is because on task number 2, we're going to configure R4 as the NTP master. R4, using that local time, is going to be providing time and date services to everybody else, except for switch 1. Switch 1, we can't do it because in order to do NTP, you have to have IP connectivity to the NTP master, and switch 1 doesn't have any IP addresses. But everybody else. Okay, so task 2A, R4 is the NTP master. What command would I configure on R4 to accomplish that? That's right, Ian's got it right. It is actually the NTP master command, done at global configuration level. NTP master. And optionally, if you wanted to, you could provide the stratum number, which says, how close to the clock source am I? In other words, this guy right here, well, he's actually getting the clock from himself, his own local clock, so it would be appropriate to call him a stratum 1 clock, because he's right there sitting on the clock. Okay, so that accomplishes task 2A. Now for 2B, all other devices except switch 1 are NTP clients. What configuration command would I do on everybody else so they can synchronize with that clock on R4? That's right, on all other devices, I have to configure the NTP server command and then point to one of the IP addresses that's reachable on router 4. It could be any of router 4's IP addresses as long as the client can reach it. So let's go ahead and just start from left to right. So let's just start with router 2. And let's just choose the 9.50 address on router 4. That's the address in subnet E. First of all, let's just verify we can ping it. Yep, we can. So then I'll say NTP, in this case, server, and I'll put in that address. And that's all I need to do. So I'll just copy and paste that command to everybody else. start with switch 2 because he's got connectivity. Oops, not there. Right there. Okay, and switch 3. Okay, and then router 4 is the NTP master, so let's go to router 1. And lastly, router 3. Okay, so that accomplishes task 2B. Now all we have to do is verify it. Task 3, verify that it's working. What command would I issue on a client to verify that it is synchronized to the master? That's right, this is the show NTP associations command. Got to be careful when you abbreviate this command that you don't offend somebody. So show NTP associations. Show NTP ASSOC. And what we're looking for here is 9.50, verifies that. And let's try detail. We've got an association ID, input packets right there. That proves. So that proves that I'm definitely associated with it. Also, the fact that we see a little asterisk here says it is a system peer. We've peered with it. If it was just a pound sign, that might be a little concerning, meaning that, okay, well, we've selected it, but a pound sign means you haven't necessarily connected to it yet. And the little tilde means it's configured, so I've manually configured that and I am peered with it. Let's go over to router 2. And there we go. And reference clock local, that means that 9.50, which is R4, is getting his clock from his own local clock source. And Ian has a question. Can we set multiple NTPs in order to provide failover? Let's try it. What happens if I do NTP server and give just a, let's give the IP address of router 3. We could use the prefer command. That's probably how we would do it. Set 1 as prefer and then 1 as the other. And let's see here. If I just do this, is it going to overwrite the previous one, or is it going to just add it as a second one? Show run section NTP. Oops. See, it just added it as a second one. So you'd probably want to mark 1 as prefer and then just leave 1 alone. Not sure what would happen. Well, let's see. Just to do a little experiment here, let's go on to router 3 that has that address, give him a clock source that's completely wrong, set him up as the NTP master and see how router 2 deals with the fact that he's got 2 NTP servers he's pointing at and they're providing vastly different time sources. All right, here's router 3. No NTP server 190.190.9.50, so let's get rid of that. And now let's do clock set, and we'll just do something completely wrong. The 20th of March, 2016, and it's 11 a.m. in the morning. Oh, actually the time has to go in front. Clock set 11 a.m. There we go. Okay, lastly, let's make him an NTP master. Okay, so how is ARG2 going to deal with that? Show NTP associations. Well, we can see here it says he's configured to recognize that. Now this is showing that 3331 is getting his clock source from 9.50, but I had deleted that. So let's go ahead and go into router 3 again and see if I can clear NTP. Nope. Nope, doesn't look like there's any clear command for NTP. Show NTP association. Yeah, see, he clearly recognizes this is the loopback address. So he says, I am the NTP master. He's not getting it from anybody. Go back to router 2. Okay, now it's switched over. So yeah, it looks like he says, okay, I've got 2 NTP masters. This one here is getting clock from himself. Notice on this guy did not include a stratum number, so he's defaulting to stratum 8. And this one here, also getting clock from himself, but looks like we're selecting the one that was configured first. So we configured router 4 first as our NTP master. That's the one we synchronized with. And now he recognizes that R3 is alternative. Let's see, how long does it take him if we lose our connection to router 4? First of all, show IP route 3.3.3.1. So right now he is, looks like he has 2 equal cost routes, VLAN 3 and VLAN 2. But, see, what I was going to do is to do a test here. I was going to shut down this interface on router 4 because I want to see, okay, if he loses his connection to that NTP master, how long does it take him to synchronize with this new NTP master? The problem is right now, in order for router 2 to reach router 3, he's got 2 equal cost routes, both of which go through that interface. So in order to actually do this test, I would need to somehow, I'm not going to do this, this is going to take too long, but I would need to open up this PPP over Ethernet connection right here so that when I shut this down, so that would involve manipulation of routes and all that stuff, and I don't want to waste our time doing that. So that pretty much concludes this section on NTP. We've accomplished all of these tasks.